Hello?
Yeah, I can hear you. How about my voice? Can you hear me? Hear me? Hello? Hello, can you hear me? How about now? Can you hear me? Hello?
We can hear you.
Right, so let me put it out. Right. So can you all hear me now?
Hello?
So how many of you are joining here?
3 of us. Actually, 3 of us are all here.
Okay,
We are
great.
joining
Okay.
with the single link.
So may I know who is talking now? Is it Hadia?
Yes.
Hi, Hadia. Okay. So let's first of all, I'm very sorry about the timings and all, right? So yesterday also we booked it, and but due to some urgencies, we were unable to continue, and today morning also we got some confusions as well, right? So I'm apologies for that, right? Let's continue. So what type of project supports you guys are expecting from us?
Actually, it's a pacemaker. It's a single chamber pacemaker, which we are thinking about doing a batteryless. So its battery will last longer than the usual timing, like 5 to 7 years, but we are enhancing the timeline of the battery.
Okay, if it's possible, Hadia, could you share us the slides, whatever you shared with us yesterday, so that we both can have a look, and I would like to ask some doubts about that also. I just need to clarify from which background you are in and which state currently you are in about the knowledge from the project, so that I can analyze
So
and
we are in
I can
Pakistan
go
right
from which
now.
point.
Okay, like we are in Pakistan, but and we are assuming that the project will be like in 2 semesters. But like there are some challenges which are currently facing.
Okay, could you please share the slides, whatever you have prepared and whatever you presented today? Is it okay?
Actually, you have disabled the slide.
Yeah, I saw that. I would like to clarify some certain doubts as well. That's what I just want to ask you to share it from your mobile phone or whatever. Could you please share it?
Yeah, like through WhatsApp. Last night I sent you by
No,
the way this
from
slide.
the Zoom itself you can share. So let
But
me.
you have disabled us from sharing our screen.
So can you see a share button at the bottom of the Zoom link in the
Yes.
Zoom? Yeah, you just click the share. Right, great. Now you are sharing your screen. Great, great, great. Good job.
Can you see it now?
I think you have just shared about the Fatima folder.
Yes.
Yeah. Could you open the slides, please?
The slides are visible to you?
Not yet. I just see the Fatima folder and FYP is simply click. You may close it again, and once again, could you try it? I think from your end it's
Okay.
stuck something. Yeah, please.
Is it visible now?
Still the folder. Still the folder. Are you Hadia? Are you opening multiple screens, or are you having multiple windows? Because whenever you share, you have to select which type of window, which file you would like to share. If you are
Just let
opening
me.
multiple, yeah. No worries, take your time, right? Be calm.
Is it visible now?
Not yet, not yet. I think you are
Please let
sharing
us.
only Fatima fold. Hadia, you do like this. You just stop sharing and again go to the share. And whenever you are pressing the share, it may ask what window you like to share. Then select this thing, the over there. Yeah.
Is it
Right.
visible?
Great, great. You have done a great job. Yeah. Now I can see it. Go ahead, please go ahead. Yeah. So you basically I can see that you have three group members. Okay.
Yes.
Right. Now you just walk me through your project, please, quickly,
Yeah,
as
this
long
is
as what
our
I
problem statement.
okay.
This is our problem statement.
Okay, okay.
Yeah, like how can we enhance the battery life of the implantable devices?
Okay, right. At this point, Hadia, I will be asking a certain questions in each and every slides because I just want to analyze what type of knowledge you are having currently. Then only I will be able to provide you some supports from the knowledge whatever you are having, right? I have to analyze whatever you are having at your backgrounds, right?
Okay.
So basically, project statements. Just be calm and in a colloquial term, you can talk to me, right? I don't need
Okay.
to talk too much technical. Just let me know from project statements means what project you are intending to do it, right? So maybe what type of problems you have observed in the market or what type of gap you have observed in order to provide your ideas and technology. So basically, I can see that you are very much interested in doing or enhancing the pacemakers, right?
Yes.
So what was the problem in the current pacemakers as long as you know?
The problem is that we have to get to an operation every 5 to 7 years because
Okay.
we have to change the batteries. But we are suggesting a new enhanced way of pacemakers in which the patient don't have to get to the operation and we can enhance the battery life.
Okay. So you just want to extend the battery life.
Yeah. For the
Okay.
lifetime.
Uh, somebody said lifetime.
Yeah, like you don't have to ever get to the operation to replace the batteries.
Oh, okay. Once operation is done, it is going to last long for his entire life. Is
Yeah.
it so? Okay. Okay. So that's your objective, extending the lifetime.
Yes.
Okay. Great. Okay. 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 Move on, please. Mm-hmm. Yeah, I saw this. So basically, is this your own idea or did you take it from some research papers?
Yeah, some things are from the research papers, but some things we added on our own.
Okay. Did you add something else here from your own ideas?
Yeah, the thing was instead of one batteries, we use two batteries, and there will be piezoelectric material. So the material will generate a voltage, and as soon as the first battery will die, the second battery will start to process, and the first battery will go to charging again.
Okay, so that's your concept.
Yes.
Mm-hmm. Okay, okay, okay. Move on, please. So having two batteries, is it your own idea or having two battery? So I just want to make sure that which point you have inserted your ideas.
Yeah, actually having two batteries are on idea. Yeah, initially there was just a piezoelectric material that was attached to the heart, and it was used for converting the heart vibration, mechanical energy from the heart vibration into the electrical energy, and then that was charging the pacemakers. But we have decided that we will actually install two batteries inside the pacemaker. And again, the same process as Fatma has already described, that when first battery, which is already charged and it has a lifespan of about 5 to 6 years,
it will be working. Then the other battery will be charging by the piezoelectric material. And once that the first battery is dead, then the pacemaker will switch to the other battery, and it will then start running. Yeah.
And this was the rough sketch we had in our minds.
Yeah, this is the rough sketch in which there are two batteries, switch, and the things you can see, piezoelectric plate on the electrodes.
Okay. Right, fine. Seems a good one. So did you present it to your supervisor?
Actually not yet. Today we have to present it to the.
So it's not done yet, right?
Yes.
Okay, great. Okay, Fadia, and now could you let me know from which
but
part?
there were
Please, what?
but there were some problems. Like if, for example, the person is exercising or is jogging or running, the heart rate will increase, okay, and so will be the voltage increased by the piezoelectric material. So we need a mechanism that the excess voltage will be discarded and not sent back to the pacemaker.
So for that problem, Fadia, of course, we can use voltage regulators. You know, there are in electronic components, we will be having so many components. As per the needs, we can choose the components, whatever we are going to handle, right? So for the problem, whatever you have just mentioned.
And the second problem was, what if the two batteries have also charged, but there is an excess voltage that is producing? So we have to maintain a ratio between the discharging rate of the first battery and the charging rate of the second battery.
For that problem, of course, you do not need to connect both batteries to get charged at the same time. So your circuit must be in a way like a relay, right? So that means at a single time, a single battery must be get charged. The other one, there won't be any connections. Once the first battery is charged fully, then it should be utilized. The power should be consumed from that battery. Meanwhile, the second battery should get. Sorry, what?
Yeah, but what if the first battery is charged and the second battery is also get charged? So what will be the ratio of discharging and charging of the both batteries? So we can get rid of the excess voltage.
No, not like that. I'm saying, so you are the ones who are going to design the entire circuits, right? So whatever the electronic things, so you all are from biomedical engineering backgrounds or electronic backgrounds?
Yeah.
Yes.
Biomedical engineering background.
Biomedical engineering, BMEs, right?
Yes.
Okay, great. So then you don't need to put too much pressures or too much technologies here. Just design the circuits because you haven't designed it yet, right? Maybe you can get the ideas from the research papers. We will be able to help you guys. I'm saying do not connect both batteries to get charged at the same time because then it will both get same. The problems, whatever you are mentioning, will be arise.
No. I'm saying the both batteries won't get charged at the same time. The only one battery will charge and the second will discharge to the pacemaker working and whenever the voltage is required.
Okay.
But what if the first battery is working and it's not discharged fully and the second battery is also charged? So there will be an excess voltage.
Okay. I got it. Yeah. So you're asking how to handle that excess voltage issues, right?
Yes.
Okay. So for these problems, I can suggest you because whenever we are doing some electronic circuits and all, you may familiar that in order to earth the circuits, right? So we have to neutralize the circuit using the maybe in our day-to-day activities or even at our homes, we can see some green wires which are connected to earth, which means neutralizing, right? The exchange amount of electricity or the exchange amount of voltage, we can do like that. Whatever the components you are having inside your body, it should be neutralized in any kind of ways.
Yes. And the second thing, how we can check the piezoelectric material means how many voltages will piezoelectric material generate per cycle or per minute. So
Okay. Okay, so this is related to some clinical questions. Obviously, we have to do some. Are you students allowed to do some clinical activities such as visiting the hospitals or cardiologists in order to collect data similar to this, or you are going to depend only on research papers and the online materials?
No, we can go on our own
So
to
are you able
hospitals
to
about
visit a
get
cardiology,
some
or
information.
are you able to get some informations from a hospital?
Yeah.
Or else, if it is possible, that's really great. Or else you can simply depend on the research papers, because in the research papers, they will be only, what do you mean? They will be only doing some research similar to this, and there will be some, we call it threshold values. For all type of bioactivities, we will be having some threshold values. What do you mean by the threshold values? Maybe you are familiarized with the term, right? So that's the maximum value we can play around in a safe manner. We can't exceed that. So we have to find the threshold value in this case, because I cannot reveal the threshold value at the same time because we haven't started the projects yet with you. Once we start doing the projects, then only we have to collect the data, and then we will be able to find the threshold values. So threshold values are the values where we will be asked,
Okay, and
yes, please, what?
yeah, there's also like some doubts that what if the person is sick and her body temperature rises? So will it affect the piezoelectric material? Because the temperature will rise and the material, I don't know if it will affect or not.
Most of the time, no. Most of the time, it won't be a problem. And again, there are so many materials and resources where they are creating the piezoelectric materials, right? So it depends. It depends. Again, we have to collect the data along with the temperature and its effects on the piezoelectric materials. Again, we have to do some research on that,
So
because most of the
will
time,
you guys,
it doesn't affect.
yeah, actually, how will you guys help us? Like through research, or will it will be a hardware, something kind of thing?
So basically, our support for academic projects, we are supporting the industrial projects as well for biomedical engineering and the hospitals. So apart from that, we are supporting the students as well. Our academic supports basically divided into three categories. If you want us to work on the document side only, that means you can handle all the hardware parts, you just need the documentations arranged, then we will be able to do the documentations parts for you only. The second type of support that you can get from us is technical supports. That means you have to take your entire documentations done by you, but we will be advising you technically what are the things you have to do and how you have to assemble the things and all technically. And the third and the final support is entire project support. That means you do not need to do much. You have to attend the regular meetings, and we will be updating you what's going on with the project. We will take care of your entire academic and the technical stuff. So these are the three types of supports that we can provide academic students.
Okay, we have a presentation in 5 minutes. We'll contact you later, okay? Now we have to go.
Sure. Yeah, we will continue the meeting later on. Okay, thank you.